Hello everyone. We'll start in 1 minute. Okay. Times out mali yung oras ko sa laptop. So 3 minutes pa pala. Ayan, 1 minute na lang talaga. Ayan, 4:10 na. Good day everyone. Hello sa mga nandito sa Zoom and sa mga nanonood sa live stream or sa mga nanonood ng recorded. My name is Ivor. Ako yung unang mag-discuss ng solution to problems sa first 3 parts. And then yung kasama ko is George. George.
Hello, my name is George. I'll be discussing the last three problems.
So, ayan, again, this is day 1 of Math 21 LE1 review. This session is brought to you by UP Mathematics Major Circle and UP Mathematics Club. So, start na natin to. Before I go to the problems and their solutions, here are some reminders to maximize your experience in today's review. First, prepare your note-taking materials or applications. You tend to forget things easily, so we recommend writing down notes from the review. Please keep your cameras, microphones of the review. If you have questions, this review will be live streamed to the MBAN 109 YouTube channel for educational purposes. You may go back to the recording after the review. This will be a 2-day review. However, you can still view the recording at the MBAN 109 Sorry na disconnect ako. Let me get back to it. Ayan, so ito yung limit problems natin. So, we prepared 5 limit 4. The rest of the solution. And also, save sa pag-recall. Lagi ako nadi-disconnect. Sorry. Ayan, again, bilisan ko na lang. So, basically, this is just a definition of limit. And then, so the limit of f of x as x approaches a is L. So, kung susulat natin siya dun sa conventional notation, ganito itsura niya. And then, remark lang, limit tells us that x approaches values closer to a, but not necessarily being equal to a. So, kahit minsan nasasanay kayo na pita-plug in nyo na lang basta yung a, it does not necessarily mean na yung limiting value, yung x nag-approach talaga sa a, but na lang, close to a lang. And yung ka-fact na yun, ma-appreciate nyo siya sa one-sided limits. Mamaya. So, theorem, recall lang natin sila. L1 is yung limit ni f. And then L2, limit ni g. Kapag constant, yung limit niya is c. Kapag isang variable lang, plug in nyo lang, kasi constant. Continuous naman si x. Tapos kapag magkahiwalay yung functions by plus or minus, then take nyo lang limits ng both functions. Then pag product sila, take nyo lang yung limit ng both functions. Tapos ito is great fact kasi kung i-compare nyo siya sa derivatives, di ba? Parang mapapadali yung buhay nyo kasi sa derivative, kailangan nyo pang product rule. And then same thing applies with integrals, not product rule pero may other ways, di ba? Tapos kapag quotient naman, take nyo lang limit ng numerator and denominator, provided that yung L2 hindi siya equal sa 0. Tapos kapag naka-raise sa exponent yung f of x, take yung limit nung nasa loob. And same thing goes with rational yung exponent, then 1 dapat yung nasa taas. So basically siya, nth root. Ganun. Tapos dapat yung f of x nyo, yung limit niya as x approaches a greater than 0. Yung mga things na to, like, be careful with them kasi baka mamaya, for example, dito sa last part, yung limit pala ni f of x as x approaches a, less than 0 pala siya. Pero dahil nasanay kayo na tinitake nyo lang yung limit ni f of x, ginawa nyo yun without even noticing that fact na less than 0. So, be careful lang doon. Sa another theorem, continuation lang natin. Kapag naka-encounter naman kayo ng fraction form, like yung numerator ay number lang, tapos yung sa baba ay variable, mag-approach sa infinity as x approaches 0, either from the left or from the right. Kapag from the left ni 0, siya, positive infinity. Kapag from the left of 0, negative infinity. And kapag mayroong factor na negative 1 sa x sa baba, basically follow nyo lang yung usual product rules ng signs, di ba? So kung from the left siya ni 0, that means negative of 0 minus. So both negative sila, di ba? So imagine niyo negative times negative yun. So magiging positive. Kaya positive infinity siya pag from the left of 0. Pag from the right of 0 naman, parang ang nangyari, negative of 0, positive. So imagine niyo na lang negative times positive, kaya negative infinity. So ayan lang. Tapos kapag naka-raise exponent, na number, constant, Bali, parang plinag-in nyo lang yung infinity, pero not technically, parang lang. Pero magandang imaginein sa ganung way para madali. Tapos general tips, kapag nagkaroon kayo ng problema sa limit, at pag sinabi kong problema from now on, ibig ko sabihin, nagkakaroon kayo ng indeterminate form sa evaluation nyo sa pag-take nyo ng limiting value. So, ito yung mga general tips. So we have 4. Try to multiply with the conjugate, and usually applicable yun kapag nakita kayo ng radical sa kunwari rational function yung na-encounter nyo, tapos may radical. It's either sa taas or sa baba, tapos meron pa siyang katabing another term, for example, 3x plus square root of something, usually mga ganyan, or 3x minus square root of something, usually conjugate yung ginagamit dyan. Pero not always, lalo na kapag limits involving infinity. Mamaya may problem tayo about that, and madidiscuss na siya. Second, separate or combine fractions. Usually naman ito nagagamit kapag may fractions. Ayan, obviously may fractions. Pero rational functions, or pwede ring hindi rational, kunwari trig over natural log, or yung fraction mo ay exponential over trig, ganun. Try nyo i-combine yung fractions kapag hindi siya nag-workout. Kasi di ba merong limit theorem na kapag separated by plus or minus, take mo yung limit ng isa, take mo yung limit ng isa. Pero what if infinity minus infinity? Eh di ba indeterminate yun? So, kailangan yung i-combine. Baka sakaling mag-workout in that way. Tapos third method or approach na pwede nyo gamitin, factor out or combine expressions. Usually magagamit nyo ito kapag nakakita kayo ng rational function. And that means na yung numerator and denominator pareha silang polynomial. Tapos pag in-evaluate or pag tinake mo yung limit niya, nagiging 0 over 0. Pag ganun yung nangyayari, try nyo i-factor out. Kasi sa mga ganyang cases, ang ginagawa lang talaga ng prof is merong factor ng monomial siguro, or usually monomial, tas maka-cancel sila from top to bottom, up or down, up and down, sorry. Basta yun yung pinaka-goal nyo, may makancel ganun. Tas last naman, approach, solve for one-sided limits. Usually sa yan, sa absolute value functions, sa piecewise functions, and sa greatest integer functions. Well, actually, lahat ng yan piecewise functions. Pero ayun, sinabi ko explicitly just to remind you guys. Tapos number 2, kapag hindi equal yung one-sided limit, ibig sabihin nun, hindi siya nag-exist. Well, actually, ito ay isang technical definition, pero nilagay pa rin siya sa general tips kasi baka lang makalimutan niyo. So yan, let's dive in na sa first problem. Ito yung limit natin. And kagaya ng sinabi ko kanina, kapag may absolute value, usually nag-one-sided limits. Pero not always, especially kung hindi naman magkakaproblema. For example, yung ina-approach ni x ay 1 lang. Pag sinubstitute nyo, di ba, lang. Like, wala namang problema eh. Hindi naman magkaka-indeterminate form. So, dito kasi, kapag tinry nyo siyang i-evaluate, ibig sabihin, pag pinag-in nyo c negative 1, magkaka 0 over 0. So, in that case, we need to check yung one-sided limits from left and the right. And then, from here, kapag may absolute value function, gawin nyo lang, recall nyo yung definition niya, tapos, isulat nyo yung function as it is, tapos yung interval kung saan siya nag-correspond ay greater than or equal to that limiting value. I mean, kung saan nag-approach si x. And by the way pala, if ever din yung pag ginagawa, try nyong sumabay or try nyong unahan ako sa pag-solve nito habang dinidiscuss ko, such that pagkatas ng discussion, mati-check nyo kung tama kayo. And also, magkakaroon din kayo ng makakapag-form kayo ng questions after this. And then yung second sub-function, lagyan nyo lang ng negative. Kopyahin nyo lang yung original function sa loob the absolute value, lagyan yung negative, tas less than that of the value kung saan nag-approach si x. So, ayan na. And then, first, take natin yung one-sided limit from the left of 1. So, ganito yung notation niya. And then, ang gagawin natin dyan, pipili tayo sa dalawang subfunctions kung alin yung isa-substitute natin sa absolute value function nito. And since from the left of -1 tayo, tayo kumukuha ng x value or doon siya nag-approach. Ito yung interval na nagko-correspond doon and nagagamitin natin subfunction ay ito. So may -x+1. Now magka-cancel out sila. So ang matitira, -1. And meron tayong theorem na kapag constant yung yung nandun sa right ni limit, yung limit niya as x approaches to something, yun na rin, -1. Now, try natin from the right of -1. We find the limit from the right of -1. Tapos, here, ang gagamitin natin pang substitute dun sa absolute value ng x+1 ay x+1 na lang. Kasi recall na yung interval na nagko-correspond sa x+1, yung subfunction na yon ay greater than -1. And yung limit natin ay from the right of -1, which means yung values na x nag-approach to -1 from values greater than 1. Kaya x+1. Tapos pagka-cancel out sila, kaya naging 1. Yun. And then, baka lang naisip nyo, bakit mas nangingibabaw yung pag-cancel out kaysa dun sa fact na pwede mo siyang i-substitute. Kasi pag sinubstitute nyo, tingnan nyo, 0, 0 pa rin, di ba? 0/0. Pero bakit pwedeng ma-cancel? Kasi, hindi naman siya, yung pina-plug in mo, hindi talaga -1, right? Close to 1 lang. So, mas nangigibabaw pa rin yung possibility na mag-cancel ka or mas pwede mong gawin yun. Kasi hindi naman talaga -1 yung sinasalpak. Close to 1 lang. Nice. Okay. Ayun na yun. Tapos, next step, compare natin kung equal ba yung one-sided limits. And then we see na hindi sila equal kasi -1 from the left, plus 1 from the right. And that means na hindi nag-exist yung limit. So, ang sagot sa number 1 ay does not exist. Limit does not exist. By the way, reminder lang din, no? Baka kasi ilagay nyo limit of f of x equals d and e. That's wrong. Okay? Nagkamali rin din ako dyan dati nung first year, nung high school. Pero baka lang pagkamali rin kayo, that's wrong. Sulat nyo lang, the limit does not exist. Huwag nyo nalagyan ng equals. Next problem, ito siya. So kung titingnan nyo, rational function ito. Polynomial sa taas, polynomial sa baba. And then meron tayong tip kanina, right? Kapag sinubukan yung i-plug in yung ina-approach na x, which is 8 in this case, magkakaroon siya ng indeterminate form. So may problema tayo. And pag ganyan yung nangyari, and the rational function, yung tinatry nyo isolve, ang gagawin nyo usually ay ipa-factor out. Ipa-factor out kayo. And ang purpose kasi nun may maka-cancel. Like, tinan nyo ang problema dito, di ba? 8 minus x, nagiging 0 siya sa baba. Kung hindi nag-0 yan, edi 0 lang yung taas, tas 0 yung limit. So, meron na kayong hint na ang kailangan nyo i-cancel ay yung 8 minus x. Kailangan nyo na lang makaisip ng factors dun sa taas, sa numerator, para makancel siya. So, tip lang dito, review nyo yung mga factoring methods. Siguro hindi ko na i-discuss kung paano ito na-factor. Or sige, yun lang. Sobrang bilis lang. So, quadratic to, may coefficient na non-negative na greater than 1. So, paghiwalayin mo lang si 2x tsaka si x, tapos tingin ka dun sa sign ng constant term, positive siya. So, ibig sabihin, same yung sign nila. And anong uri ng sign? Negative. Tingin ka sa middle term, negative yung sign niya. So, ibig sabihin, parehong negative. So, ayan, naglagay ng negative, negative. Kasi factor out yung si 8 in such a way, kapag minultiply nyo yung 2 factors na yan, mag-equal sa dito. Bali, parang trial and error na lang yun. Kung pipiliin nyo ba yung 2, 4, kung pipiliin nyo ba yung 1, 8, tapos kung anong location nila. Kaya nyo na yun, guys. Review nyo na lang din. Tapos dito, makikita nyo na may maka-cancel out. So, na-achieve natin yung goal natin na i-cancel out si x minus 8 kasi problema yan sa madalas, lagi, kapag gustong i-test ng prof nyo yung understanding nyo sa ganitong process. Usually, tapos may indeterminate form. So, kailangan matest yung skills nyo sa pag-factor out. So, ayan. Na-factor out, negative quantity 2x minus 1. Tapos from here, wala nang problema. Pwede nyo nang isalpak si 8. So, sinalpak nyo, 16 minus 1, 15, negative 15, yung final answer. Ayun. So, sana tama kayo at sana sinasabayan nyo ako. And sa mga nanonood din sa YouTube ngayon, so, sana tama kayo. Kung mali kayo, okay lang yan. Practice lang. Next, third limit. Ayan. Mukha siyang rational function, pero hindi siya rational function, ha? Okay, rational function kapag both numerator and denominator ay, tawag yun, polynomials, may radical sa baba. Tapos kanina may tip na sinulat, usually kapag merong radical, nagko-conjugate ka. Pero not always the case. Kasi, tingnan nyo dito, limits involving infinity to eh. Tapos kung pinanood nyo yung lecture video sa iMath, meron naman nun, di ba? Tinuro doon na ang techniques to solve this kind of limits, i-divide yung numerator at denominator sa highest exponent. So, tingnan nyo itong nandito, ang highest exponent ng up and down, numerator at denominator ay x raised to 5. Pero, pag x raised to 5 kasi, pag dinivide nyo sila both, yung taas at baba, pagkakaroon ng dito, ng square root of 10x raised to 10 minus 1 over x raised to 5. Kasi hindi nyo yun pwedeng makancel. Hindi siya mag-approach sa 0, unlike yung nasa taas. Like, ito kasi, pag tinanggal nyo x7, pag tinanggal nyo yung x raised to 5 dito sa numerator, may matitirang 7, kasi itong negative 8x cubed magiging negative 8 over x squared, tapos mag-approach yun sa 0, and same with this negative 1, magiging magiging negative 1 over x raised to 5, kung x raised to 5 yung pinili nyo, tapos mag-approach yun sa 0 as x goes to negative infinity. Ang problem nga kasi, sa square root of 9x raised to 10 minus 1 over x raised to 5, faster growing function itong square root of 9x raised to 10 minus 1. And hindi ko na siya ipapakita, pero pwedeng i-prove. Gawin nyo lang i-assume nyo first na faster growing function sa x raised to 5, kasi yun yung gusto nyo mangyari. So meron kayong inequality, kasi ito 9x raised to 10. Tapos from that, manipulate nyo na algebraically, square nyo both sides, tapos magiging magiging x raised to 10 is greater than 9x raised to 10 minus 1. Tapos, take nyo yung derivative both sides. Ang mangyayari, so x raised to 10, So 10, pag tinake nyo both sides derivative, magiging 10x raised to 9 is greater than 90x raised to, x raised to 9, which is wrong kasi 90x raised to 9 is greater than 10x raised to 9. So maling inequality, and therefore, dapat mo siyang baliktarin para maging tama, and that means na faster growing function tong nasa loob ng radical or itong mismong expression to. So hindi siya magiging 0. Ang kailangan mong gawin dito ay i-convert mo yung x raised to 5 in the form na may radical para madama yung nasa loob ng radical. And usually, mapapakinabangan nyo yan sa mga ganitong uri ng problems. So, pag may nakita kayong radical, try nyo lang i-manipulate yung highest exponent in such a way na magiging radical siya. Kagaya dito, tingnan nyo to. Ano dapat yan, di ba? X raised to 5. Pero sinulat siya as square root of x raised to 10. So, square root, x raised to 5 pa rin yan. Tapos ngayon, minultiply na yung fraction na yan dito. So, ayan, na-distribute lang. Tapos, yung x raised, ito, yung 1 over x raised to 10, na-distribute siya dun sa loob ng nasa radical. And now, may important note. Sa number 3, may ganun siya. Hindi ka na-conjugate yung sa radical kasi pag tinry mo, mas mahirap siya. Like, tinry ko siya kanina, mahirap eh. Like, kasi di ba ang purpose sa radical, kapag kasi simplify siya pag tinake mo yung limit. Kasi pag tinry mo yun, hindi siya ganun kasimple. Like, pagkakaroon ka pa rin ng negative infinity sa baba, and then yung sa taas, parang infinity pa rin. Or pwede kang mag-factor out, pero hindi siya straightforward. Like, try nyo, makikita nyo. Actually, hindi ko pa sineryoso, pero baka mas tama kayo. I mean, pababaw na calculation lang yung to kanina, pero nakita ko na hindi siya ganun ka straightforward. So, ayan yung reason. Tapos ngayon, tinake natin yung definition ng absolute value na x raised to 5. Bakit? Pwede naman x raised to 5 na lang Kasi, recall, negative infinity to eh. So, magmamatter yung absolute value. Yung definition ni absolute value as piecewise. Pero kung infinity lang yan, imagine niyo. Hindi nyo na kailangan to. Like, pwede nyo ilagay agad yan eh. Wait lang, sorry. Mamaya ko na sagutin yung mga questions niyo after this. If may mali kayo, basta mamaya na lang. So, ito, ayan, nasa ba ako? So, sa negative infinity, and yun yung reason kung bakit tinake natin yung definition ni absolute value. So, alin sa dalawang sub-functions yung pipiliin natin? Pipiliin natin ay negative x raised to 5 kasi negative infinity siya. So, ayan, may message si paki-note. Nag-approach siya from negative infinity, so less than 0 yun, kaya negative x raised to 5 yung sinubstitute. So, yung mga square root of x raised to 10 magiging negative x raised to 5. Except dun sa nasa loob, kasi naman sila like x raised to 10 na sila. Nasa loob ng radical line. Wait lang, bakit ayaw lumipat? Ayan. Yan, yung negative x raised to 5 na, nakita nyo. Tapos, x raised to 10 pa rin nasa loob ng radical. Tapos from here, simplify na lang. And then ito, pwede nyo nang magamit yung theorem na kapag merong fraction, tapos number yung sa taas, and then variable na x raised to a number, non-negative and greater than or positive, basta positive yung exponent, nag-approach sa 0. So, ayan. Ano ba tawag dito? Yeah. Simple na lang to after that. Kasi magka-cancel out yung ibang terms. Tapos, basic arithmetic na lang yan. Kaya nyo na yan, guys. Ayan yung sagot. 7/15. Next. Limit. Ayan.
Hello. May tanong po sila sa previous na... Okay, wait lang. Hindi natin kayo. Okay, rinig po ba ako?
Yes, rinig.
Okay. Una, yung wala sa loob ng square root, pwede ba siya i-multiply sa 1 over negative x to the 10?
Wait lang Like, nabasa ko rin yung question niya. Sorry. Yung wala naman po sa loob ng square root. So, itong mga terms na to, pwede po ba siya i-multiply sa 1 over, hindi negative sa 1 over x raised to 10. Ano bang mangyayari pag 1 over x raised to 10?
I think I can answer this question. Okay. Yung sa loob... Okay, dinig ba ako?
Yes.
Okay. Ito kasi, yung x to the... Okay. So, the square root interacts with others. Okay, joke lang.
Kasi, kapag 1x, pag tinry mo sa 1 over, negative ba yan or nag-typo ka lang? Kaya assume ko na nag-typo ka lang kasi, basta, same lang naman eh. So, kunwari, 1 over x raised to 10. Yeah, 1 over x raised to 10. So, magiging 7 over x raised to 5, 8 over x raised to something. So, magiging 0 to. Pero ang problema mo itong radical. Like, sure ka ba na na faster growing function yung x raised to 10 kaysa sa square root of 9, x raised to 10 minus 1. Natry ko ano ba mas faster growing function? Yung x raised to 10 ba or or yung square root na yun? 9x raised to 10 minus 1, x raised to 20. Hindi. Oh. 9x raised to 10 minus 1, x raised to 20. Faster growing x raised to 10, cancel out. So magsi-0, 0 siya. Kasi tiningnan ko ngayon lang, faster growing function yung x raised to 10 kaysa sa kaysa sa square root of 9x raised to 10 minus 1. Pero posible na mali ako, kaya check nyo rin. Simple lang naman yung algebra. So mukhang di naman ako nagkamali. Yeah. So kung faster growing si x raised to 10, magsi-0 out. siya. 0 yung taas, 0 yung baba. So, i-determinate yun. Kaya, this is a better way of doing this. Ayun, sana nasagot yung tanong mo. Tapos may tanong kasi kanina, bakit di po kinonjugate? Parang nasagot ko na siya, right? Pag kinonjugate mo, hindi ka matutulungan nun. Kasi magiging komplikado pa rin. Okay, sana kung 0. Kung 0 kasi yung in-approach ni X, mag-0 yung negative 1. Hindi rin pala kasi kung nag-approach sa 0, magkakaroon ng imaginary number. So, hindi rin pwede. Kasi naman ako, ayun na, tapos na. 715.
Required po ba kaya sa LE na maglagay ng note yung piecewise function po?
Wait lang, sorry. Hindi ko ganong narinig.
Okay, required po ba kaya sa LE na maglagay ng function, maglagay ng note yung piecewise function po?
Hindi naman required actually. Hindi naman required, I think.
Hindi siya required, pero kung gusto nyo, pwede.
Yeah. Like, lalo na kapag ano lang naman, kung absolute value of X, like obviously, kapag from the left siya, kunwari 0, from the left of 0, edi negative X na yung ilagay nyo. Or, para mas mabilis, huwag nyo na talagang ilagay kahit ano pang function yung nasa loob ng absolute value. Basta sure kayo na tama yung ilagay nyo. Okay, proceed na ako. Naubusan ako ng oras. Ayan. Ito, hindi na edit, sorry. Okay, itong note na to, mali siya. Hindi siya indeterminate. So, umpisa pa lang. Kasi magiging negative infinity and minus infinity. So, minus infinity na siya. Yung next up, yung alternative approach na hindi pinakita dito, take nyo lang yung limit separately. Take yung limit separately. And makikita nyo na negative infinity minus infinity. Pero dahil wala sa slide, ang i-explain ko ay kung ano yung nasa slide. Para lang din ma-emphasize yung technique na pagsamahin yung two fractions. So meron kang two fractions and then ano lang tawag dito, factor out mo yung isang denominator. So magkakaroon ng magiging x minus 2, 3x plus 5, tas LCD nila x minus 2, 3x plus 5. Tas from there, I think kaya nyo na yun. College na kayo, madali lang yung process na yon. So ganito, makakancel yung 5 and 5. Titira 3x squared minus x. From there, ang problema nyo lang dito yung itong term na to, yung x minus 2, di ba? So, yung other parts kasi pag tinry yung i-plug in si 2 negative, yung one-sided na 2 from the left, wala namang problema. Hindi nyo na kailangan maglagay ng sign, di ba? Try nyo, 2 squared 4, 12 minus 6, so 6 lang. Huwag nyo nang lagay ng note na 6 from the left or from the right. Pag 0 lang yon. Kasi kapag 0, usually, lalo na pag nasa ibaba siya. Kung nasa taas naman, kunwari, fraction, nasa taas si 0, 0 pa rin yun, either from the left or right. Pero pag nasa baba, maging sensitive kayo sa sign 0. Yung sign na tinutukoy ko, yung one-sided 0. So in this case, anong uri ng 0 to? 2 from the left. So ibig sabihin, mas mababa sa 2. So pag nag-minus ka, so something na mas mababa sa 2, minus 2, negative yun. Sige, mag-apili tayo ng specific example. Kunwari, 1.59. Di ba? Close to 2, but less than 2. 1.59. Tapos, plug in mo yun dito. Minus 2. Anong sagot? Negative 0.01. So, ang negative 0.01, from the left siya ni 0. So, 0 minus yung lumabas. Tama ba? Mali ba ako ng sinabi? Yeah, from the left of 0 siya. 0 negative. Tapos dito naman, hindi na tayo naging sensitive sa sign. Plug in nyo lang kasi hindi naman siya nag-0. Ayan, 0 negative times some number. Ano yun? Negative yun. I-follow nyo lang yung usual convention ng multiplication ng signs. So, negative siya. So, negative 0 yung sa baba. And then, meron tayong kanina, right? Tawag yun? Theorem. So, pag may fraction ka, number sa taas, tapos sa baba, 0 negative. Diba? 0 negative. Nag-approach siya sa negative infinity. Kaya negative infinity yung sagot dito. So, exercise lang para sa inyo. Try nyo siyang isolve separately. Take nyo yung limit itong first term. Take nyo yung limit itong second term. and negative infinity minus infinity makakuha niyo. Pinapaulit nila, bakit daw negative x raised to 5? Tutuloy ko ba? Sige, saglit lang naman yung explanation na yan eh. Kasi, nag-approach siya negative infinity. So, kung nag-approach siya sa negative infinity, yung interval na pinanggalingan ni x, less than 0. Right? Less than 0. So, negative x raised to 5. That's the ba? Ayun lang. Last problem para sa limit. Ayan, meron tayong theorem na di ba? Yung kapag sine of x over x, tapos nag-approach sa 0 sa x, yung limiting value niya is 1. So, almost, yun na yun eh. Halos kamukha niya na. The problem is, nag-approach sa infinity si x at hindi si 0. Tapos yung argument ni sine ay function ni x. Pero okay lang yun kasi, di ba? Basta, tuloy ko na to. So, in this case, mag-introduce ka ng variable para maging some variable approaches to 0, yun nasa ilalim ni limit. And yun ay, ang pinili natin ay e raised to negative x. Tapos, notice that kapag nag-approach sa infinity sa x, nagiging 0 si y. Kasi di ba, itong e raised to negative x, equal siya sa 1 over e raised to x. Kapag nag-approach ng infinity sa x, so isipin nyo 1 over e raised to infinity is equals to 1 over infinity, and that is equal to 0. So y approaches 0. Now, i-rewrite na natin siya in that way. Limit of y goes as a limit of y over sine of y. So y approaches 0 is equals to 1. Actually, pwedeng hindi nyo na to ilagay. Kasi di ba dun sa lecture vid ng ng IM, if napanood nyo na, yung generalized na theorem is limit of sine of f of x, so kahit anong function ng f of x over f of x as x approaches 0 is 1, as long as yung f of x mo nag-approach din sa 0. Pag hindi siya nag-approach sa 0, hindi yun applicable. So yun, parang ganun din to, nag-approach siya sa 0 eh. Pero pinalitan mo lang yung yung nasa ilalim ni limit. So, pero pinakita rin natin, pinakita na lang din yung yung elaborate step. Bakit equal lang yung theorems na si y nasa taas, tsaka dun sa version ng theorem na si y nasa baba. So, ganito yun, 1 sa taas, tapos ito yung actual theorem na sinasabi ko, pag-equal yan sa 1. Kasi ito yung theorem, kanina ko pa sinasabi, nandito lang pala, equal yan sa 1, nag-approach yan sa 1, sorry. So, ibig sabihin, equal to sa 1. So, ayan, 1 ang sagot. Ayan, tapos na tayo sa limits. Sana marami kayo natutunan or na-consolidate man lang ang inyong knowledge about that.
Hello, actually may nagtanong pala.
Yan.
Can you go back sa previous?
Yes. I mean, what? Sa direct message ba? Basahin ko? Next question.
Sige, proceed na tayo.
Proceed na. Mamaya ko na lang sagutin. Okay.
Yes.
So, continuity yung next part na i-discuss ko. Okay? So, sa continuity, ang pinaka-general tip or siguro, basta lagi yung tatandaan, meron 3 conditions ng continuity. Dapat define siya doon sa function, yung function value niya, defined at a particular point. Yung limiting value niya, then exist at that particular point. And third, equal sila. Yung function value at limiting value ay equal at a particular point. Tapos ito yung problem, determine daw natin kung continuous or discontinuous itong piecewise na to sa points na x equals 0 or x values pala, x equals 0 and x equals 1. So ngayon, kapag discontinuous siya, classify din natin kung anong uri ng classify rin natin kung anong uri ng discontinuity, removable, jump essential, or infinite essential. Okay. Bago natin sagutan yung problem na yon, review lang muna natin. Nabanggit ko na pala ito kanina. So you have, technically, meron kang region na D na subset ng XY plane, ng real plane. Tapos yung A mo, nandun siya sa region na B, yung function mo, define siya as this one, tapos magiging continuous yung function kapag define yung function value at A, nag-exist yung limiting value at A, and equal yung function and limiting value at A. So, yun. Tapos removable kapag hindi equal yung limiting value and function value. Pero pwede rin na nag-exist si limiting value tapos si function value at define. In that way, removable pa rin siya. So hindi necessary na na define to tapos hindi sila equal. Pwedeng undefined yung function value tapos nag-exist to. Pero pag hindi nag-exist yung limiting value, then jump essential siya. Okay? And pwede rin na hindi nag-exist, hindi undefined si f of a, tas does not exist si limiting value, jump essential. Kasi infinite essential naman, ayun, basta may infinity. Kung both sides infinity, goods. Kung one side infinity, kung yung one side lang infinity, okay na yun. You can conclude na infinite essential siya. And then pwede rin na function value ay undefined. So not necessary na define siya. Ayan, sagutan na natin yung problem. Check natin kung continuous ba siya at x equals 0. First, function value, defined ba? Of course, hindi siya defined. Kasi, check muna natin anong subfunctions yung pipiliin natin sa dalawa. Pipiliin natin itong may absolute value kasi x is equals to 0 and 0 is less than 1. So, nagpo-correspond yung subfunction na to, dito sa interval na to. Kaya yun, pinili. Tapos, ayan, kapag plinag-in nyo, hindi ito kasama, sa sa limits. Pag plinag-in nyo na si 0, maging 0 over 0, so undefined siya. Ngayon, kung yung tanong, discontinuous ba siya, tapos hindi na pinapa-classify kung anong uri ng discontinuity, tapos ka na doon. Okay? Kapag na-prove nyo na undefined siya at a function value, then pwede nyo nang i-conclude na discontinuous siya para din makatipid kayo sa oras kapag nag-exam kayo. Mamaya na yung tanong, please. Tapusin ko daw muna to. Then the function is undefined. So, doon na tayo sa limit. Check natin kung nag-exist yung limit niya. And gagawin natin to kasi nga, pinapa-classify kung anong uri ng discontinuity. Kung hindi pina-classify, tapos na yung step, dito pa lang sa first step. So now, proceed tayo sa next steps. Piecewise, limiting value niya as x equals to 1. Piecewise siya. So, ibig sabihin, mag-take tayo ng one-sided limits as x approaches 0 pala. And since unahin natin ang from the left of 0, so balikan natin yung definition ni function. Aling subfunction ang pipiliin natin, yung nasa taas, kasi from the left of 0 and from the left of 0 is less than 1. And yung nagko-correspond na function ay ito. So yun yung pinili. Tapos ngayon may absolute value function na naman. Tapos, i-recall lang tong definition ng absolute value. Pero kung gusto niyo ng shortcut, kahit niyo na isulat yan, isipin niyo na lang from the left of 0. So ibig sabihin, negative yung gagamitin niyo na function, hindi positive. So ganun lang yun. Pero makikita niyo naman dito sa definition niya. From the left of 0, less than 0. So negative x. Ayun na yun. As from here, factor si x minus 1 yung matitira sa loob, makakancel yung x. Tapos, ayan, magiging negative x plus 1. Tapos, plug in nyo si x, plug in nyo si 0. Hindi nyo na kailangan maging sign sensitive kasi 0 naman yon and wala namang infinity or wala namang indeterminate forms na involved. Kaya, 1, hindi nyo na kailangan asikasuhin yung one-sided 0 na yun. Next, from the left of 0 naman. From the right pala, sorry. From the right of 0. Now, ang pinili nating function ulit ay yung may absolute value function. Kasi from the right of 0, less than 1 pa rin siya. And close to 0 to Even though from the right of 0 naman si 1, pero close to 0 dapat. So, ayan. pinili yung function na may absolute. Tapos, ayan, in this case, positive si x kasi from the right of 0. So, greater than 0 yung values nag-approach. Tapos makakancel yung x, matitira x minus 1, negative 1. Tapos makikita nyo na yung one-sided limits nila hindi equal. Kasi dito, negative 1 siya from the right, tapos 1 siya from the left. Kaya, does not exist yung limit. And since hindi equal yung one-sided limits mo, jump essential siya. So, yun yung condition ng jump essential. Not equal yung yung one-sided limits mo. Now, check natin yung continuity niya sa x equals 1. First condition, di ba, function value. So, ano ba yung function value niya at x equals 1? Okay, so since piecewise siya, pipili ka ng sub-function. Ngayon, ang basis mo sa pagpili, ano ba yung saang interval ba included sa x equals 1? Of course, dun siya sa interval na x greater than or equal to 1. So, ang pipili mo yung my greatest integer function or floor function. From now on, floor function ang itatawag ko sa kanya para madaling sabihin. So, now, evaluate na lang natin at x equals 1. So, pag ginagin mo si x equals 1, so magiging 2 minus 1. So, 1 ang sagot. And recall na kapag nasa loob ka ng floor function, nagra-round down, tapos whole number naman siya. So, ayun na yung niya. Ayun na yung greatest integer function niya, 1. Tapos 3 yung sagot dito. Tapos, next naman, yung limits niya. Take natin yung limits niya as x approaches 1. And then, again, piecewise siya, di ba? So, pag ulit tayo, one-sided na naman. Unahin natin yung from the left ni 1. So, kung from the left siya ni 1, pipiliin natin sub-function ito. Kasi yung 1 minus, included siya dito sa interval na x less than 1. Tapos, again, here, hindi na natin to consider yung sign ni x or hindi na natin ni-recall yung definition ni x kasi kahit i-plug in mo siya, wala namang problema. Like, ayan, tingnan nyo, wala namang problema dyan, di ba? So, 0 lang yan. So, magiging sensitive lang kayo dun sa absolute value kung may problema kayo. And again, by definition, ibig sabihin sa problema ay pag may 0 sa baba, ganun, or may indeterminate form, ganun. Pero kung madali lang naman i-evaluate and define naman, hindi na kailangan. Pero kung gusto nyo maging consistent, sige, gawin nyo na lang din. Magiging negative x, maka-factor out. So, ano siya? Negative of quantity x plus 1. Ganun din. Next na. May correction daw na hindi ko napansin. Pero mamaya ko na yung kaya siya. Mukhang sinasagot ni DM yung sorry. Pag-focus na lang ako dito. And then try kong magitin yung tapos na yung from the left of 1 and ano ba yung limiting value niya as x approaches 1 from the right. 1 naglalag ako. So ayan, from the right of 1, anong interval yon included? Of course, itong interval nito, yung x greater than or equal to 1. So yung obviously yung nagko-correspond na sub-function for that is itong my floor function. Kaya yun yung ginamit natin. So, take na natin yung limit nitong sub-function na to. Tapos, notice that kapag nag-approach si x sa 1 from the right, diba? The values of x are greater than 1. So, bigay tayo specific example. For example, from the right of 1, 1.01. Tapos try nyo i-plug in 1.01. 2 minus 1.01. Ano yun? 0.099. Right? Yeah. Sana tama ako. Yeah. So, less than 1 yung 0.99, di ba? Okay. And since less than -1 siya, or hindi pa lagit yung mismong 0.99, pag ni-round down nyo yun, di ba, magiging 0 siya. Or, ano ba? Yes, ayun na yun. Ulitin ko lang, again, kapag pag tinry nyo mag-isip ng values close to 1 pero less than 1, ay greater than 1, tapos pinag-in nyo, kunwari 1.1 naman na yun, tapos minus nyo 0.9, round down nyo yung 0.90. So, 0 siya. Now, pag may value, pag ginawa nyo na yan dun sa mismong limit, so magzi-0 na tong floor function. Tapos 0 na rin yung buong function dito sa limit. So, equal siya sa 0. Gets? Ayan. Now we know na 0 yung limiting value from the right of 1. Tapos, 0 din siya from the left of 1. And since equal sila, ibig sabihin, yung limiting value niya as x approaches 1 ay 0. Tapos, i-compare na natin yung function value at limiting value. And we can see na hindi sila equal. So, we conclude na meron siyang removable discontinuity and discontinuous siya. Nasabi ba na discontinuous siya? Or din sinabi? Hindi nasabi separately. Pero ayun, discontinuous siya and ang type of discontinuity ay removable discontinuity. Ayan, last problem na tayo, which is intermediate value theorem. So ito yung function natin, tas ipoprove natin na meron siyang root sa interval, sa closed and bounded interval. Mahalaga yan mamaya. Because closed and bounded interval na 2, 4. Pero before the solution, recall muna natin yung theorem. So if meron kang function and dapat continuous siya, like hindi siya sinabi explicitly, pero itong statement na to, binabanggit niya yung conditions, okay? Maging careful tayo sa conditions. Mamaya, i-explain ko kung bakit, i-emphasize ko kung bakit. Continuous si f, tapos interval niya ay closed and bounded. Tapos, yung function values sa endpoints not equal. So, 3. Okay? May tatlong conditions. Hindi siya sinabi explicitly, kagaya ng continuity, pero magiging mahalaga siya. Now, ang sinasabi ng theorem, pag nasatisfy yung tatlo na yon, meron kang for every k sa pagitan ng f of a and f of b. By the way, y values to ha. Imagine niyo itong tatlo, f of a, f of b, k, sa y sila ha. Tapos, yung corresponding nila, x coordinates, yung katapat nilang ganun, merong nag-exist na c in the interval na ab, tapos yung ab nasa x-axis siya, such that pag pinag-in mo yung x value na yon, sinulat siya dito as c. Pag pinag-in mo siya sa function, equal siya sa k. Okay? Ngayon, reminder lang din na hindi sinasabi sa theorem na unique yung c. So, pwedeng marami. And usually yung theorem na to, applicable siya sa mga roots problem. For example, ipoprove mo na yung particular function, meron siyang roots, at pag sinabing roots, may values na x, na kapag in-evaluate mo yung function, magiging 0 yung function. Okay? Tapos ngayon, explain ko kung bakit gano'n. Wait lang. Okay. Explain ko muna yung intuitive approach or reason yung tawag dito. IVT. So basically sinasabi niya, kapag nasatisfy mo yung 3 conditions, una, continuous, di ba? Kung continuous siya, sigurado ka na yung function hindi magbe-behave weirdly, like hindi siya magkakaroon ng asymptotes, hindi siya magja-jump, hindi siya magkakaroon ng butas, or hindi mag-isolate yung isang point. Niya at those endpoints ay not equal. Ibig sabihin, pataas, hindi siya pantay, like pwedeng pa ganun, hindi ganun ha. So hindi pantay. Kunwari, yung f of A nasa baba, f of B na ganun. Tapos yung function mo pa ganun. So, kung ganun yung isura ng function mo sa particular interval, close and bounded, sure ka na madadaanan niya lahat ng points. Basically, yun lang yung sinasabi niya. At kung madadaanan niya lahat ng points, pwede mong i-prove na nag-cross siya at a particular y value. Right? Kasi di ba ang y value sa xy plane, kunwari, y equals to 2. Tapos gusto mong i-prove na nag-cross yung function sa y equals to 2. Gamitin mo itong function na to. And then i-prove mo na yung 2 ay nasa pagitan ng f of a and f of b. So, graphically, meron kang function. Ito yung f of a, ito yung f of b, tapos yung y equals to nandito sa gitna. And kung yung function mo continuous, ibig sabihin, sure ka na magdadaan siya dun sa line na yon. So basically, ganun lang. And the same thing applies sa zeros or sa roots. Ang kaibahan lang, ipoprove mo na yung f of a nasa baba ng x-axis, f of b nasa taas ng x-axis. Hindi na pala ako mag-annotate kasi sana na-explain ko ng maayos. Sagutan na natin yung mismong problem. Okay, first part, syempre yung conditions, kailangan i-prove natin na na-satisfy niya. So first condition, continuity. Prove natin na continuous siya. So notice that yung polynomial part, ito yun, yung x minus square cube, tsaka yung minus 3x over 2. Continuous siya. At yung polynomials, continuous sila sa everywhere, sa real number line, sa x-axis. So negative infinity to infinity. So yung logarithmic part, continuous siya from 0 to infinity. And then, yung whole function na yan, continuous siya dun sa tawag dito, sa intersection nila. So 0 to infinity. And yung closed and bounded interval na 2 to 4, 2 to 4, and included siya dun sa interval kung saan continuous yung ating function. So we can say na continuous yung function sa closed and bounded interval na meron tayo or na concerned tayo. So now, nasatisfy na natin yung first condition, which is continuity. Now, i-prove natin yung second condition naman. I mean, hindi naman sila hierarchical or walang order. Gusto ko lang talagang banggitin continuity muna bago yung order. Pero yung isa pang condition, which is yung close boundedness, obvious naman, right? Close bounded siya kasi brackets. Tapos walang infinity sa interval. Yung endpoints niya hindi infinity. Tapos brackets din yung ginamit, hindi parentheses. And kapag hindi kasi ganun, kapag hindi close bounded, pwede yung, ang ilalagay, kunwari, lumabas yun sa exam nyo, ilagay nyo na lang na hindi applicable yung IVT. So magandang shortcut yun. Kasi malay nyo, yung prof nyo, pinagtitripan lang kayo, gusto kayong i-test. Like for example, masyado kayo nag-focus sa steps, tapos kinalimutan nyo yung conditions, tapos hindi kayo naging careful sa close boundedness ng interval, diba? Check nyo rin yun. Now, yung third condition naman, inequal dapat yung function values sa endpoints. So check natin, evaluate natin siya sa 2. Pag in-evaluate mo siya sa 2, may mali dito, ano to? Negative 8. Tapos ayan, hindi ko na rin chinek yung ibang Sige nga, check ko. So, negative 3. So, ayan. 2. Okay. A half. Okay. Naman. Aside from negative 8, mukha namang tama na lahat. Tama ba? 7. Pa-check na lang kung may mali pa. Okay. Wala ako sa ngayon. Basta, i-evaluate mo lang siya sa function values. If may mali man dito, typographical siya. Okay? Pero negative 13 over 2, parang mali nga siya kasi negative 11 yun. Negative 22, tapos 9. Okay. May nag-shot. Okay, tama yung sagot. Negative 8 lang dapat. Now, yung function value sa right endpoint. Yung x equals 4. And mali na naman to, sorry. Typo. F of 4 dapat yan. So, pag in-evaluate mo siya, ayan. I mean, arithmetic lang to. So, kung may mali na naman, pa-check na lang. Pero mukhang wala naman, right? Yeah, wala naman. Yeah. Okay. So, 3. Tapos now, na-prove na rin natin na hindi equal yung function values. Tapos, pwede natin i-apply yung IVT, okay? And gusto natin i-prove na may root si function, kailangan natin i-show na yung 0 ay nasa pagitan ng function value sa endpoints. And since negative 13 over 2, yung function value sa left endpoint, and then yung function value sa right endpoint ay 3. And clearly, nasa pagitan si 0 ng dalawang yun, then we can conclude na may root si function sa interval na 2, 4. Or pwede kang maghanap ng values ni x na kapag sinubstitute mo sa f, magiging 0 siya. So, ayun lang. Tapos na lahat yung problems. I think, dapat ko na bang sagutin yung mga tanong nila? Pa-confirm naman para makukuha yung ano. Ano ba yung Q&A?
Okay, sige. Ask na ba tayo? Okay, ano daw? Are the exams in Math 2X multiple choice?
Hindi. Right? Kasi sa Math 23, hindi, di ba? So, I assume na sa Math 21, hindi rin. Yeah, I think hindi talaga. Kasi nakafocus sila sa solutions.
Yun.
Okay po.
Hindi siya multiple choice. Parang yun lang ata yung tanong eh. Yeah, yun lang so far. Yung ibang mga tanong, hindi siya related sa mga diniscuss mo. Sagutin na lang natin mamaya. Yeah.
Okay, mamaya na lang. And
Thank
also,
you, Iver.
We'll be having a break pala, 5 minutes break. Then mamaya, balik tayo, sagutan ng tanong Q&A. Ayun lang. Ang next na lecture ay si George. Ayun lang, bye-bye.
Okay, so hello everyone. I'll be discussing the second half topics. I hope that you have enjoyed your break. So now let me share my screen. Okay, so just let me present. Okay, so now the latter half will be focusing more on squeeze theorem, derivatives, differentiation rules, and last but not the least, differentiation. So now here is the problem for squeeze theorem. So using squeeze theorem, evaluate the limit as x approaches negative infinity of 7 floor of x plus pi all over 2 minus 9x. So take note na hindi natin ito basta-basta pwede ma-substitute since we have an unfamiliar function in the name of floor of x. We need to assess first kung paano natin gagawin itong problem na to. So before we start, squeeze theorem is super helpful sa mga types ng problems na to. And now let's discuss about it. So now let's recall na ang squeeze theorem has three functions, f, g, and h, and they are defined in an open interval I containing a, except possibly at a, such that there are two conditions. F of x must be less than or equal to g of x is less than or equal to h of x for all x in I except possibly in A. So, pasensya na, I will edit this later. Then next na condition ay yung limit as f of x approaches A ng f of x is equal to the limit as x approaches the same A ng h of x equals L. So, bale, to visualize the situation, I'll annotate here. Meron kang isang graph dito. So, bale, let's say this is f of x. Tapos, let's say, kunwari ito pala yung f of x, itong nasa baba. Tapos meron kang h dito. Then kunwari, ang g of x mo is somewhere in between. So let's say gumanyan siya. This is, let's say, this is g. So now let me highlight this a bit. So ito yung point of intersection nila. So, yung ibig sabihin ng squeeze theorem, pinipit-pit ng h at saka f yung function ng g at a particular point, which is itong nasa orange na point. So pwede siya kahit saang points, basta ang importante, squeeze theorem squeezes both functions and that's the limit ng gitnang function. So as you can see here sa last part, then if nasatisfy yung dalawang conditions, yung limit ng g of x as s approaches a is equal to L. So bakit ito yung gagamitin natin for this problem? Let's see about that sa ating solutions. So now let's proceed sa solutions. Okay, so as you can see, notice na for any x less than 0, ang floor function natin is always between etong x minus 1 at saka x. So when we try to multiply this by 7, wala namang mangyayari dito. So 7 times x minus 1 is less than, yung floor function is less than 7x. So what we're doing here actually is we're building up yung original function natin kanina, which is itong 7 floor of x plus pi all over 2 minus 9x. And take note na since kaya x less than 0, since we're finding the limit as x approaches negative infinity. So ngayon, from here sa second line, we're gonna add pi on each of them. So ganyan yung itsura niya. And then, we're now gonna divide 2 minus 9x dito. And as you can see, bakit walang sign change dito? Because for x less than 0, 2 minus 9x will always be greater than 0. Kaya wala siyang sign change na dito. So now, since we know already yung mga functions niya in between, which is itong nasa kaliwa at saka yung nasa kanan, we now evaluate each using squeeze theorem. So, just as is, limit of x approaches negative infinity, now left function is 7x plus 7 minus pi over 2 minus 9x, which is equal to, take note na pag sinubstitute mo to, magkakaroon ka ng indeterminate value na negative infinity over positive infinity, which is still indeterminate. Kaya we're gonna multiply this by 1 over x both sides. So ito, mapapansin nyo na multiply siya. Then we have 7 minus pi over x, tapos 2 over x minus 9. And we know na this approaches 0, so makakancel na agad siya. And we are left with -7/9 sa left part na limit. Likewise, ganun din yung solution dito sa kanan. So, multiply lang 1/x since magiging indeterminate form. Then we have 7 minus 7/x tapos 2/x minus 9. Kaya -7/9. And take note, nakikita mo, equal ang limits nila. As you can see here, since equal yung limits nila, and in between tong function na to, dito sa dalawa, therefore, our function by squeeze theorem, yung limit niya is equal to yung limit ng dalawang functions na pinipit siya at that point. So, since negative infinity, somewhere dito sa dulo siya napitpit dito. So, ayan. So, ayan yung sagot natin. So, may question ba sa chat or kay Will?
So, walang nag-ask sa akin.
Okay, sige. So, now we'll answer the other questions na in general or yung mga previous questions.
Mamaya lang.
Okay, so now let's proceed with problem 5 if wala nang tanong. So now, we're going to find derivatives. We're going to differentiate the following equations or functions. So now we're finding dy over dx or the derivative of y with respect to x of the following. Do not simplify. So meron tayong dalawang case. Yung una, itong y equals 5 raised to cot x minus 6 sinh x all over square root of ln sine x is yung unang case wherein you just need to find the derivative. So I'll show you later kung paano. Ito naman, sa second case, we notice na y appears in both sides. And we cannot really find y itself, unlike dito sa number 1. So we're gonna do another practical method here. So now let's try to find, recall what are derivatives. So first, the definition of the derivative is a function f of x denoted by f prime of x, pwede ring y prime, depende sa convention ng prof nyo or anything that you feel na gamitin. Is a function f prime of x equals limit as delta x approaches 0 ng yung difference ng x plus delta x minus f of x all over delta x. And take note na itong form na to is actually yung slope form. So bale, parang let's say, I'll draw here. I annotate ko siya dito. So kunwari, let's say may function ka. So pasensya na medyo orangey siya. So ganyan. So bale, ang nangyayari is that may two certain points ka. Let's say this is point B, this is point A. So hanapin mo yung slope niya, which is of course y component tsaka yung x component. So bale, ang nangyayari dito, as delta x approaches 0, lumiliit siya ng lumiliit, pupunta siya dito. Ito naman, pumupunta siya dito. Until such point, meron ka ng tangent line somewhere here. And ito yung slope ng tangent line na nandito sa curve na to. So yan yung visualization ng ating derivatives. So now let's see theorems regarding derivatives. Okay, sorry. Naka-mouse pa lang. Okay, let's proceed. So remark lang, huwag kayong kabahan kasi usually hindi siya lalabas sa exam. Puro mga derivative theorems naman ang lalabas sa exam. So you'll not suffer that much pagdating sa exams kahit 2 hours yung limit niya. Okay, next naman. Ito yung mga general theorems natin na gagamitin. So let f of g be function that exists and c be in the set of real numbers. Then, derivative ng c is, since constant yan, 0 na agad yan. Then we have power rule. So derivative ng x raised to n equals nx raised to n minus 1, where n is in Q. So bale, kahit ano siya, kahit fraction yung nandyan, ganyan yung lalabas na derivative. Then next, derivative ng constant times a function is equal to constant times yung derivative ng function. So bale, pinasok lang itong d over dx sa loob. Next naman, sum rule. Bale, derivative ng sum ng functions is just the derivative ng sum or difference ng mga functions. Then, product rule, take note, f of x, g of x, yung derivative niya is not f prime of x, g prime of x, but rather itong f prime of x, g of x plus f of x, g prime of x. Then last but not the least, may typo dito. Dapat ano to? Dapat may over to. Naka-fraction siya. So, wait lang, sorry. Fraction to. F of x over g of x equals itong f prime of x, g of x minus f of x, g of prime of x all over yung square ng g of x. So, bali, usually yung notation nito, let this be u, let this be v. Usually yung memorization ng ibang tao dito, for product rule, u prime v plus v prime u. Dito naman, u prime v minus naman v prime u all over v squared. So usually ganyan yung notation ng mga ibang tao dito sa akin. Sa quotient rule. Okay? So kung curious ka kung paano na-derive, you can try it on your own. You'll need to use the definition of derivative, which is ito. Or you can just use the properties if na-derive mo na sila. Okay? So next naman natin na i-discuss is yung chain rule. So bale, we'll discuss later yung differentiation. Ito na muna. If a function g is differentiable at x equals x naught, and a function f is differentiable at g of x naught, then f of g of x is differentiable at x naught, and yung derivative nito, f of g of x, is simply f prime of g of x times yung derivative ng g of x, which is g prime of x. Take note, kaya sa chain rule, paloob siya. Parang chine-chain ng outer derivative yung mga nasa loob. Kaya papansin mo, pag f of g, composition function siya, so nadadamay sila sa derivative. Kaya you need to multiply them. Okay, last but not the least, ito na yung for problem 5b, implicit differentiation. So to find dy over dx using implicit differentiation, so we should always think na a function y is a function variable x. Or let's say, kunwari hahanapin mo a function x with respect to y, ganun din yung process. So kunwari dx over dy naman, ito naman with respect to y yung i-differentiate mo. Now, next step is differentiate both sides of the equation. Tapos hahanapin mo ngayon yung dy over dx. So with that aside, let's now solve the problems for differentiation. So first problem, itong y equals 5 raised to cot x minus sinh x all over square root of ln of sine of x. So take note na this is in the form of a quotient ng dalawang functions. So we can apply quotient rule there. And since iba-ibang mga variables, we'll use chain rule dito sa part na to. So let f of x equals ito and g of x equals ito. Notice that kapag hinanap mo yung derivative nila, this is f prime of x equals yung derivative ng 5 cotangent of x is 5 cotangent of x times the derivative ln 5 kasi yan yung derivative ng 5 raised to x. Then since may cotangent x yan, hahanapin mo yung derivative ng cotangent x, which is negative cosecant squared of x. Tapos ima-minus mo ngayon sa derivative ng plus mo pala sa derivative ng sinh of x, which is just cos of x. Kaya wala nang sign change. Dito naman sa g prime of x, ln of sine of x squared yan. So bababa siya. Initially, yung mangyayari is itong 2 square root nito. Tapos yung derivative ng ln of sine x, which is itong sine x. Tapos derivative ng sine x, since nasa loob siya, which is itong cosine x. So take note na palabas, paloob yung form natin sa chain rule. Okay? So now with this in mind, we know na how to compute yung ating quotient rule, which is dy over dx. So bale, take note ulit na f prime of x, g of x times minus g prime of x, f of x all over yung square nitong baba, which will give us eventually itong f prime of x, tapos annotate ko lang, f prime of x, tapos ito f prime of x, g of x. Take note na hiniwalay ko to kasi hindi na to makakasya sa beamers. Then square lang net ln of square root of ln sine x is just ln of sine x. Tapos ima-minus mo siya dito sa derivative ng square root of ln of sine x. Then i-multiply mo siya dito sa original na f of x mo. Okay? So ayan yung derivative nitong function na to. Then last but next na tayo sa B naman, implicit differentiation naman tayo. So now we are given 3 ln y plus itong 10 over x minus 4 raised squared equals 5x1 arcsine of y cubed plus 1. Take note na yung sine negative 1 dito is usually denoted as arcsine, hindi sine of x raised to negative 1 or 1 over sinus which is cosecant x. Iba siya sa exponent dito. So to differentiate both sides with respect to x, take note na may y dito, kaya naging 3 over y dx dy over dx siya. Then, pwede mong palitan to y prime kung nasa hihirapan kayo sa dy over dx. Tapos, differentiate natin ito. That's just negative 2, kaya negative 20 na to, times x minus 4 raised to negative 3, kaya nandyan sa denominator. Equal siya sa derivative nitong 5x plus 1, kaya 5x plus 1 ln 5 lang yan. Tapos arcsine nito. Then yung derivative ng arcsine is actually 1 over square root of 1 minus x squared, which is itong 1 minus y cubed plus 1 squared. Tapos, i-multiply mo rin siya sa chain rule, 3y squared, then may dy over dx ka pa. Tapos, i-multiply mo to sa 5x plus 1. So now, we rearrange this, kaya ganito yung format. Lahat ng mga dy over dx nasa one side. Then yung mga wala namang ganyan, nasa other side. Then eventually, ang makukuha nating sagot is we isolate lang dy over dx and we divide this dito sa right-hand side. Kaya ito yung sagot natin. So may questions ba tayo for differentiation or derivatives? Pati implicit differentiation chain rule or wala? Will?
Hello, sorry. Ano yung tanong?
May tanong na ba on your side?
Okay, wait lang Actually, meron. Yung iba, sagutan natin mamaya. Okay, reminder pa lang, yung recording, ma-upload siya doon. Yung ma-upload yung recording sa YouTube, guys. Okay? Sige. Wait lang May nagtanong, bakit po 20 over x minus 4 cubed?
Okay, sige. Balikan natin siya. Oh, ay, wait lang. Ito, sige. So, bale, take note na if you make this into a, ilagay mo siya sa numerator, ano siya, 10 times x minus 4 raised siya sa negative 2 since nasa denominator siya. So, yung derivative nito, ilagay mo to dito sa kaliwa, i-multiply mo siya. So, kaya magiging negative 20. Tapos, yung exponent na to is negative 2 minus 1, kaya x minus 4 raised to negative 3 siya. Ito, negative 3. So, pag nalilito kayo sa ganitong format, i-convert nyo muna to negative exponents, tapos saka nyo na lang ulit ibaba kung nalilito pa.
Yeah. The person who sent that question said that the explanation helped a lot. Thank you, George. Okay. Acceptable po ba if ang differentiation for G... Ano yung number? Pwede ba balik tayo sa number 1?
Sige. Okay. Ito.
Okay. Acceptable po ba if ang differentiation for g of x for number 1 is 1/2? Ang complicated ng explanation. Okay, ang complicated ng expression. Ang differentiation for g of x for number 1 is 1/2 ln of sine of x to the power of negative 1 over 2 times 1 over sine of x times cosine of x. Yan yung tanong.
Yeah, okay. That's just another form assuming na lahat nasa numerator. Ako nga, I would argue na if papasimplify pa kayo ng prof, you can simplify this itong cos x over sin x into cotangent of x sa numerator. So, bale, magiging cotangent of x to. Tapos nasa numerator na siya. Ganun. Ay, depende naman sa prof yan. Pero kung hindi na simplify, I suggest play safe, wag nyo na i-simplify kasi makakomplicate buhay nyo, baka mag-careless pa kayo. Kasi I did that once na rin sa exams, kahit online lang. So,
okay, pero by the way may nagtanong din. Usually po ba hindi naman pinapasimplify? Usually oo. May awa yung math prof sa inyo, guys. Hindi sila magpapasimplify ng complicated expression. Okay? May awa sila. Okay. May nag-ask din, saan po nanggaling yung LN? With which problem is this? Saan siya galing? Saan po nanggaling sa last problem? Sa 2 ba? Sa problem 2 po tayo.
ito. Ito siguro yung tukoy niya. Yung sa 5 raised to x plus 1, tapos ln5. So, bale,
Okay.
yung derivative kasi ng, wait lang, sorry. Naka-laptop kasi ako kaya hindi ako makasulat na maayos. Yung derivative kasi ng a of x is always equal to a of x, tapos palaging may ln of a yan. So, pansin mo pag derivative ng e raised to x is just e raised to x. Pero kapag other constant na siya, ito yung format niya palagi, yung derivative niya. Kaya pansin nyo, 5 raised to x plus 1, ln 5, tapos wala na akong derivative to x plus 1 kasi understood na yun na 1 lang siya. Pero feeling ko, if depende sa prof, baka kailangan nyo pang expand yan. So to be safe, pwede nyo i-expand times 1 para sure lang. Okay, may tanong pa po ba sa audience?
Actually, meron pa. Okay lang ba?
Yes, walang problema.
Okay. Sa first problem naman, is it advisable to change 5 to the power of cotangent x to e to the cotangent x ln 5 to apply the e to the u derivative? Yes, I can answer this question. You can try it out. If you do that, you'll end up getting the exact same answer. Yeah. Okay.
Actually, yun din yung ibang method. Pag kunwari medyo nahihirapan sila mag-derivative yan, you can convert it muna, tapos hanapin mo na derivative. Okay. Meron pa, Will?
Hello, I think that's it. Thank
Okay.
you.
Sige, you're welcome. Okay, so if wala nang tanong, let's proceed na sa last problem. So now we're gonna find the differentiation at this point. So a derivative of a function f of x is given as, usually, ang elegant gumawa ng mga math professors ng mga problems, hindi nyo mahahalata na just from the concept, like, concept and then application. Ito yung isa sa mga favorite kong mga types ng problems kasi mapapaisip ka talaga kung paano mo masasolve yung mga problems. Okay, so let's try this. A derivative of a function f of x is given by f prime of x to be 2 cos of x minus 4 if x is less than 4, and e raised to ln of x squared minus 3ax plus 2a squared minus ln of x minus 2a if x is greater than or equal to 4. So what must be a such that f of x is differentiable at x equals 4? So usually pag mga ganito, kakabahan na yung mga tao kasi ang medyo feeling complicated tignan. Pero let's try to himayin natin to step by step. So before that, let's try to first define differentiation. So meron tayong, actually, like sa limits, meron tayong one-sided derivatives, meron from the left, meron from the right, and this is just derived from the definition of a derivative. So ano lang yan? Definition lang yan. Then, ito naman, one important thing sa theorem, kasi ito na yung shortcut version niya. So f prime of from the left of x naught is just the limit of f prime of x as x approaches x naught from the left. Tapos vice versa naman dito kapag from the right naman i-approach natin. And now, we define differentiability. So, a function f is differentiable at x equals x naught if and only if yan yung if na yan, f prime of from the left of x naught and f prime plus from x naught are equal, exist, tapos equal sila, tapos equal pa sa f prime of x. Although usually, kapag differentiation, may times na yung interval mo, balikan ko lang to, yung interval mo minsan, pwedeng greater than 4 na instead of greater than or equal to 4. Pero, kung na-prove mo na equal lang yung mga left and right hand derivatives, you can just say na f prime is just equal to itong 4 na, f of 4 mismo. Okay? So, general tips, check if the function is continuous, pinaka-importante, at a certain domain, consequently to the point of interest. If hindi na siya continuous, you cannot say na, you can say na agad na hindi na siya differentiable para hindi na kayo mahirapan. If it's continuous, syempre we add an additional layer itong definition natin to check its differentiability. Then next, for piecewise functions, yun nga, yung parang sinabi ko kanina, may mga intervals na hindi mag-equate sa certain value. Like kanina, if kunwari x greater than 4, hindi na siya mag-equate sa x equals 4. If you want to find the point, check its differentiability. So, bale, yung importante dito sa differentiability, itong first two na equations. Okay, so now with all that, let's try to himayin natin yung problem. So, for the solution, if f is differentiable at x equals 4, then automatic we use the theorem na ang limit, ang left at right derivatives ay equal. So, bali limit lang to as x approaches 4 from the left is equal to x approaches 4 from the right. So, bali, take note na from the R given dito sa taas, notice na from the left, wait, sorry. Nakaano ko lang. Wait lang. So, notice natin from the left na ang approach niya from the left is itong 2 cos of x minus 4. Then from the right naman, ito from the left, tas ito, para may guide kayo. Sorry, na ano lang, malaki lang. Ito from the right, kasi x greater than equal to 4. So you'll use that dito sa ating equation as you can see here below. So now, we substitute lang itong 2 cos of x minus 4. I-take the limit as equal to itong limit na to. So bali, ano lang yan, sinisimplify lang natin ln. We just use the property of natural logarithms. In consequence, yung natural logarithm natin. Okay, so now, ito. Kaya naging ganyan yung equation niya kasi e raised to ln of x is just equal to x. Kaya may ganito na siya. And take note na, from this, we can factor out actually itong equation na to. So, actually, ano na pala, pwede ka pala mag-substitute since wala namang problema sa limit. Since ano naman we're just substituting na. So, bale, if we substitute this, we have 2 cos of 4 minus 4 equals, we substitute lang yung 4 dito, and we get na, ito, 16 minus 12a plus 32. Kasi ano to, 4 squared, 16 times 2 is 32. So, actually, ano pala to? Sorry. This should be 2a squared. This, may typo ulit tayo. Pasensya na. This is should be a. Kaya, ito, 2a squared. So, bale, cos of 4 minus 4 is actually, so recall lang na ang cos natin e raised to x plus e raised to negative x over 2. Kaya papansin mo plus e raised to negative x over 2. So pansin mo kung 0 yan, this will just be equal, this will equal to 2. So 2 over 2 equals 1. Kaya matitira dito yung 2. Tapos, we multiply lang itong 4 minus 2a dito, kaya nagiging 8 minus 4a equals itong nasa numerator. Okay, with that in hand, mangyayari is that, isi-simplify, iwa-one side na natin yung a. So, mangyayari, ito, lalabas pala na a squared minus 4a plus 4 equals 0. Then we can just, we know that this is just a perfect square trinomial, kaya a minus 2 squared siya. Then, wala namang, hindi naman nagmamatter positive, negative, since ano naman yan, 0 naman yan. So, a minus 2. So, we get a equals 2. So, yan yung value ng a such that magiging differentiable na yung ating equation. So, if you want, you can try to check it for yourself. Ano naman? So, bale, if you substitute dito, so, di ba kanina, ano yan, tawag dito? Wait lang. So, bali, if you substitute 4 dito, lalabas x equals to pala, equals to x minus 4 yan, and magtataka, paano ko masasub to? Pero take note na if you substitute 2 dito, magiging ano na siya, factorable, so makakancel mo na to eventually. So, if you're finding the limit, you don't need to worry about this. Okay, so next. So, ayun, I think this is it for differentiation. May tanong pa from the audience? And since this is the last one, we can ask the general questions.
Okay. May tanong ba kayo regarding question 6? Kasi problem 6? Kasi wala nang tanong regarding problem 6, guys. Clear siya ba sa inyo, guys? Yung problem 6. Okay, I'll wait like 30 seconds. May 15 minutes pa tayo eh. 20, 19, 18, 17, 16, 15, 14, 12, 10. Ay, marami na akong counting. 10, 9, 8, 7, 6, 5, 4, 3, 2. Okay, meron nga. Okay. Bakit yung 2 cos of 4 minus 4 naging 8 minus 4a? Sa first line dito. Slide na ito. Ito naging 8 minus 4a.
Itong 8 minus 4a, okay, sige. Recall lang natin na yung cos of cos, x, ano lang yan, yung form niya, pag in-expand mo, feeling ko itatanong lang ng prof to. Kasi usually, they'll question agad this lang. So just to be sure, expand nyo na lang siya. So e raised to x, sorry, medyo na boses ko. Plus e raised to negative.
Wait lang nga, actually, can I interrupt? Kasi yung paka-gets ko dito, cos of 4 minus 4 is 1, I think. I mean, di ba?
Wait lang, ito na. So,
Typo ba to?
yes, hindi siya typo.
Okay,
Actually,
sige.
ano talaga yan? Kasi kung 0 yan, dapat wala na yan dyan sa wala nang 8 minus 4, 8 yan.
Gets. Kasi nalipat yung denominator, no?
Yes, nalipat yung denominator. So, bale, if you substitute 0, since 4 minus 4 is 0, lalabas e raised to 0, which is just 1, tapos e raised to 0 ulit, which is just 1 all over 2. So, 1 plus 1 over 2 is technically equal to 1. Kaya, ano yan? 2 times 1 yan. 2 times 1. Then, mamomultiply mo lang itong 4 minus 2a dito sa 2. Para na-multiply both sides by 4 minus 2a. Kaya, ang lalabas, 4 times 2, 8. Tapos, negative 2a times 2 is negative 4a. Kaya, itong 8 minus 4.
Did that answer your question, guys? Yes, daw. Nakakatulong talaga yung explanation mo. Okay. May nagtanong. Ang epsilon delta at slope intercept po ba ay magiging part ng exam? Slope intercept po, baka. Epsilon delta, hopefully not. Like, actually, most likely hindi siya.
Based on experience, wala talaga siya. Yung kahit ngayon definition Pero siguro yung slope, more on lang. We'll discuss it more sa dito, yung sa slopes.
Yeah, okay. May question. Ay, wait lang nga. Ano yung unahin kong question dito? Wait lang nga. Mag-release ba tayo ng samplex? Yes, di ba?
Yes, we're gonna release a samplex. Abangan nyo soon.
Okay, sige. May pa-provide mo bang list ng formula sa LE or need po i-memorize lahat?
Okay.
I think need nyo i-memorize. Sorry. Okay.
Yeah.
Kasama po ba yung ang proving limits using the definition, using delta epsilon? Probably not.
May malaking chance na hindi siya kasama. Based on experience, at least nung online, wala kaming kasama. Tapos sa past LEs, siguro wala. Pero yung may ibang samplex na i-include yun. Pero lang yun for practice yun. Pero usually hindi siya talaga kasama. And then, sorry, nakalimutan ko yung isang na-mention mo aside dun sa definition limits.
Ano yung isang na-mention ko? Hindi ako sure eh. Okay, wait lang. Wait lang Okay. May na-miss out pala tayo. Someone wants to ask a question about problem 5. Pwede po ipa-explain ulit yung G prime of X.
Okay, sige. Ito ba? Ito ba yung tinutukoy niya?
Tama ba? I think so.
Okay. Sige. So, bale, yung denominator natin is actually itong square root of ln of sine x. So, bale, g prime of x is basically yung derivative nitong square root of ln of sine x. So, bale, yung mauuna is yung square root. So, usually 1 over 2 square root of x siya. And, shortcut ko lang slight. Pero, usually, pakita nyo lahat ng solution kasi medyo keen yung mga professors dito sa solutions pag math 21. Although pag higher math, hindi na masyado. So, dito, kaya may 2 ln of sine x dito. Yan yung derivative ng square root of ln sine x. Now, by chain rule, we need to also find the derivative nitong ln of sine x, which is just yung 1 over x. And just substituting lang, that's just sine x sa denominator. Kaya nasa denominator siya parehas. Tapos pinagsama ko lang. Then last but not the least, ln of sine x, we need to find also the derivative of sine x by chain rule. Kaya may lumabas dito na cosine of x sa numerator. Okay ba?
Did that help down?
Okay.
Hello? Okay,
Yes.
okay. Okay, wait lang Sige, i-run down ko muna. Okay. i-run down ko yung mga frequently asked questions. I'll read them aloud and answer them aloud para lalabas na sa recording. Will the slides be given? Yeah, pero correct namin yung mga typo. Di ba, George?
Yes, tama.
Okay. Will the recording be available on YouTube? Yes.
Yes.
Saan? Sa MBAN 109 YouTube account. Saan yung link niya? Di ako sure saan siya ngayon, pero we'll send it later. We'll send it, basta. Okay. Ano pa? Ilang items yung LE? We're not sure ilang. Sige, go George.
So, bale, actually, it depends every year. Basta expect nyo, may mga, siguro, I think, basta less than 10 items siguro. Pero, like everything has a subpart. So, expect na lang na mas marami than usual yung mga tanong. And then, nga pala, I almost forgot. May nagtanong yata about formula cards. You need to memorize them. Kasi yung mas mahalaga sa math is yung solutions rather than yung sagot na mararating. So kahit mali kayo sa sagot pero okay naman solution, usually medyo minor lang naman bawas, lalo na kung careless ka sa problems. Ayun.
Okay, ano pa? Ano pa yung tanong? Mahirap ba yung Math 21 exam? Ang daming ganang tanong.
Siguro based on experience, depends actually. Ako sakto lang kasi depende naman kasi yan eh. Kasi ako ay talagang mahal na mahal ko si math kaya medyo okay siya for me. Some others, yung mga nasa-struggle talaga sa math, medyo mahihirapan. Pero yun talaga, it's a subjective experience. So depende na lang on how you see it pagdating ng examples ko.
Yeah, your mileage may vary talaga sa math. Ako, math major ako. Medyo ligo ako sa math 20. Pero ayun. Ano pa yung mga tanong nila? Do we need a different blue book kada exam? Yes. Kasi yung blue book ay good for one exam only. Ano yung blue book? Ano siya? Parang maliit na blue notebook na kung saan ka nagsusulat ng solutions mo. Lagi ganun sa UPD. Magkano yung blue book? Hindi ko alam. Tanongin nyo yung mga guard nyo. Okay, ano pa? Kasya ba yung solutions namin sa blue book? Dapat oo. O dapat. Okay. This is a very nice question. I don't think we have enough time to answer this. If we have, pero how do we memorize the derivatives of the trigonometric and hyperbolic functions and their inverses too?
Oh my God.
How do we memorize them? Very good question.
Based on
Kaya
experience.
natin explain ngayon.
Okay. Ako na muna. Based on experience, actually, nagsosolve lang talaga ako. Tapos parang, yung iba kasi medyo intuitive na siya. Like, parang nakapattern halos yung mga nila. For example, I think sa inverse, parang let's say yung inverse sine, yung derivative niya, tapos inverse cosine, I think halos parehas lang sila. Parang siya, nakapattern lang talaga siya. Let's say, for example, sa inverse tan at saka inverse ng cot, yata I think may sign changes lang ng onte. So, yung mga ganong small things dun sa mga formulas, pansinin niyo yung pattern niya and try to check kung maa-apply nyo. Ganon. Ganon yung technique usually. Tapos practice lang ng practice sa mga problems. You'll get it eventually.
Jabber. Okay, isa pang tanong sila. Wait lang Ano to? Wait lang. Ang tanong ulit to. Okay, hanggang graph sketching ba yung LE?
Yes, hanggang 2.7 tayo sa Math 21. Like, buong unit 1 at unit 2 kailangan yung i-aral. At saka also, one more, please do not memorize lang yung formulas. As a tip from a math major, mas maganda kung iintindihan niyo yung formula kung bakit ganun nangyayari. Minsan nga maganda yung visual cues niya. Like, okay, ganito pala siya, kaya pala ganito yung function niya, kaya pala ganito derivative niya. Mga ganun. Try to find some patterns din sa mga formulas na ibinibigay sa inyo. Or if you want, like sinabi ko kanina, you can try to derive the formulas on your own. Kahit sabihin mong medyo tedious siya, eventually, parang for me, parang nakakagets yung formula kapag dinerive mo siya. At saka mas nakaka-absorb sa utak. Ganun.
Okay, may nagtanong ulit. May group sketching talaga po? Okay. In experience, you can be almost sure, almost certain na may graph sketching kayo. Okay? Sa lahat ng tanong, yung graph sketching yung pinaka-sure ako na magkaroon kayo sa exam nyo. I'm sorry.
Yeah.
Ganun
Don't
talaga.
worry kayo sa graph sketching. Pero don't worry.
Almost exactly. Pero may day 2 tayo.
Yes, we're gonna focus that.
Okay, wow. Kaya ba natin mag-overtime? Tanong, if A is equal to 2, ito mga, mas mabilis to. How many items typically per unit? Depende. Minsan 1 lang, minsan 4 or so. Okay. Pag bumagsak ka sa first LE, bagsak na po ba yung grade? Ano, George?
Hindi. Kasi ano yun eh. Di ba may breakdown dapat kayo ng subject? Usually, I think that's 30% yung per LE, tapos 40% yung mga homeworks. So, pag basta bumawi kayo sa ibang LE tapos sa homeworks, carry nyo ipasaya.
Ayan, Jabber. Okay. How to memorize trigo identities in just a few days. Okay, wait lang Yung mga tanong na to, how to memorize derivatives, how to memorize identities, they're very good questions. If we have enough time tomorrow, and hopefully meron, baka sakaling try natin sagutan. Baka. Okay lang ba, George? Okay lang ba?
Yeah, okay lang. Walang problema.
Okay, we can give more, yeah. Pero there's methods naman. Ano pa yung tanong nila? Okay, ito medyo tasya ba to sa 3 minutes? Okay, wait lang Okay, sa nagtanong na ito, hindi ko sabihin pangalan mo. If A is equal to 2, then the second subfunction of f prime of 4 is equal to blah 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 blah. Okay lang ba na mag-overtime? Okay, last question na lang. Okay, wait lang. About sa curve sketching, bukas natin sagutin lahat. Okay? Sige. Sa Wednesday, sa day 2. Okay, kaya natin. Okay. Ano pa? Required pa rin po ba yung final exam if mataas makuha sa LEs?
That I'm not sure. Pero feeling ko record kasi ano siya eh. Final exam, alam ko walang final exam sa Math 21. 2 LEs lang.
Okay, wait lang Can you wait may small questions saka yung sagutan agad?
Sige.
Yun na yun. There are some questions na hindi nasagutan kasi medyo mahaba yung solutions. So try nyong i-ask ulit tomorrow. I'll try to keep note of your questions. In the meantime, yun na yun. Yan na yung day 1. Sana na-enjoy nyo yung explanation namin. Yeah.
So, kung wala nang tanong,